Hello guys, welcome back to VC Tech. In today's video, we are going to be diving into another most powerful security feature on a layer 2 network, which is DHCP snooping. If you've ever wondered how to protect your network from rogue DHCP servers, incorrect IP assignments, or man-in-the-middle attack, well, this video is for you, because we are going to break down what DHCP snooping is, why it is important and how it works, and step by step I'll walk you through on how to configure it on your Cisco switch. So sit tight, and if you're new to this channel, like and subscribe. With that being said, what is DHCP snooping? DHCP snooping is a layer 2 security feature that prevents rogue unauthorized DHCP servers to pretend to be the main DHCP server on a network. It also ensures that clients only receive IP addresses from trusted DHCP source. So how DHCP snooping works is a switch classifies its ports as trusted or untrusted ports. Now, untrusted ports cannot send DHCP server messages. DHCP snooping also builds binding table with IP address, MAC address, VLAN, and port. It also blocks illegitimate DHCP offer and acknowledge packets. So the benefits of DHCP snooping is it stops rogue DHCP server from becoming the main server, as it also prevents man-in-the-middle attack, and it ensures that the IP address that the client will be receiving are going to be accurate, as it also supports additional security, which are IP source guard and DAI, which we'll be talking about in the next video. So for this tutorial, we are going to be using two DHCP server. This will be serving as the real DHCP server, while this one will be serving as the rogue DHCP server. Now we have to configure on the switch the ports that are the trusted ports and the untrusted ports. So whenever these devices here want to receive IP address, they would know where to get the IP address from. So I want you to see a DHCP snooping as a bouncer for a DHCP traffic. And with that being said, let's configure that on the switch so you get a knowledge about what it is. Take note, guys. This is FA0/2, which is connected to our real DHCP server. That is where we want to configure our trusted port. But before we do that, we have to say IP DHCP. We have to enable that globally on the switch. So we say IP DHCP snooping. By doing this, we've enabled DHCP snooping on the switch. Now let's also assign the trusted port FA0/2, and we want to say IP DHCP snooping. Then, as you can see here, we have trust and limits. For this, we'll be using trust because we only want the client, the host devices in the network, to get their IP address from a trusted DHCP snooping port, which is going to be FA0/2. So we are going to say trust. So this is what we did here, guys. First of all, we activated DHCP snooping globally on the switch. We told the switch that we are going to be using DHCP snooping on it. And remember what DHCP snooping is. DHCP is the bouncer that allows DHCP traffic. So after doing this, guys, after the DHCP enabling on the switch globally, we also assign the trusted ports that will be assigning IP address to the host PCs on the network. Let's also do this. Let's say IP DHCP Snooping, and we want to say VLAN 1 because all our ports are in VLAN 1. I'm going to show you that. Do show VLAN. So as you can see in the VLAN 1, that is where we have all our ports. All the ports are in VLAN 1, so that is why we said VLAN 1 right there. So after this whole configuration, let's try to get IP address. As I've already configured IP address on this, I've assigned IP address to the DHCP and also configured IP address on the DHCP server. For this DHCP server, it is going to be assigning the IP address of 192.168.1.1, and it's going to be assigning that IP from, it is going to start from .10 to assign IP address to the host devices. While on the rogue device, I have also configured the IP address to be 192.168.2.2. So it is on a different network. However, we've configured trusted here, and let's try to get IP address from the host devices. As you can see, guys, we are able to get 192.168.1.10 from the trusted network, which is this one. However, we are not able to get from this device because we've told the switch that whenever that the host devices, whenever this device is over here want to get IP address, they should get it from the trusted port, which is this device over here. Now let's try to deactivate that network and see what happens. Let's deactivate the cable and see if the other DHCP that is connected to the same network can be able to assign IP address to the host devices on the network. Remember, this device, this DHCP server has the IP address of 192.168.2.0. So if the host devices should be requesting for IP address, they should be getting an IP address of a .2 network that will be starting. The IP address will start from .30 as we have here. Now let's check that on the host PC and say static and go back to DHCP, and what do we get? We would not be able to receive a valid IP address because we don't have a DHCP server that is trusted to the switch. Now let's do something else. So this is a rogue device, right? And this rogue device is not on a trusted port, so it means it cannot assign IP address to the host PCs. But how about we check on a different port? So let's check the FA/2 interface and see what happens. Let's try to manually assign. Oh no, let's broom. So take this out and let's manually assign the cable to it and see what happens. Remember, guys, we told the switch that we only trust interface FA0/2, which is the interface that the rogue device is connected to right now. I want you to understand that the port is what the switch recognize. So if the switch say, okay, FA0/1 or FA0/2 is the trusted port, that port is the only port that is supposed to assign or give IP address to host devices on the network. Now let's try to get IP address again from this network and see what happens. Now we are able to get 192.168.2.32. You see, previously we were not able to get IP address, but now we are able to get IP address. And now let's also check that device that we called the real device. let's connect that device to another port and let's see if it's going to be able to assign IP address to the host devices as it did previously. So it is going to be taking FA0/1. Now let's also disconnect. Well, let's still leave the network together and let's try. Then I will also disconnect. You see we are still receiving the IP address from the previous DHCP server, which is this server over here. Now let's try to disconnect the server and see if we are still able to get IP address and if the previous real DHCP server would be able to assign IP address to the host devices. So let's try. As you can see, guys, this is how DHCP snooping works on a switch. It tells the devices where to get, or the trusted port that is supposed to assign IP address to the client. So with that being said, guys, I believe this video helped you understand how DHCP snooping works, how to protect your layer 2 device from rogue DHCP servers. If it helped you, give your boy a like and subscribe, and also follow for more video as we have something to talk about in the next. Thank you, guys.